in AP Computer Science A FRQ, number 2. So this question involves two different classes that are used to process log messages such as the ones given below. The log messages format are the machine ID column description, where you're going to have exactly one column and you won't have spaces in between. Now remember that you want to make sure that you read this carefully, read part A, B, and C, and then try to code it yourself before actually going over the answer. So therefore they provide the following class, and notice in this case your main Java is just for us to be able to test on Replit. This is not something that you guys will be able to see on your AP exam. We have your log message here where they provide you with two private variables, instance variables. They both are strings. One of them is the machine ID, the other one is your description. Notice that part A, you're going to have to implement your constructor. Part B, you're going to have to implement your contains word, which is going to return a boolean. And it's going to return true if the description of the log properly contains the keyword that is the parameter that you're taking in. And then it has two getter methods that you probably will be using on part B or part C. Notice that one of the things that you have to keep in mind is that sometimes they are not going to um, provide you with some instance variables, constructors, or methods. So not everything will be there. They're basically all the things that you need to use and enough information to be able to implement part A and B and C later on. Let's go through part A. In part A, write the constructor for the log message. So we have the log message here, and we're going to implement your constructor. You must initialize the private data of the object, which are those two variables, two strings. And so the get machine ID is going to return only the machine ID, and get description is just going to return your description. Notice that sometimes there'll be other methods that we are going to include on Replit. That's just for us to allow us to be able to test it. But there are other methods that are not listed on your actual description for the FRQ. It is important that you guys take the time to read through this carefully to make sure that there's no other information that you have missed. So in this case, see if you can actually implement part A, your constructor. That is the easiest part of this exercise. Go and pause it and see if you can try it. Okay, so in this case, we have your message, and it's going to be separated by a column. So notice that each of them is going to be column, where this is going to be your machine ID, and this, the rest, will be your error. So we need to be able to look for the column. So we are going to create an index, in a variable index called an int index, that's going to be storing the location of the column. So that is coming in as a parameter from message. So it'll be message dot, and what can I use? Which method of the class string can I use? So index of, and I'm looking for a column. And once I have the column, then I know that the first part of your string will be your description. So therefore your description is your machine ID. Will be part of your message. So we're going to have to use a substring. So message. So in this case, if the message was web server column, web server will be your machine ID. Now, one of the things that you want to do, you want to make sure that you don't want to take any risk. So let's write the first one. And let's see, do I have enough space? I have enough space here. So I'm gonna write down enough space. So we have web server. Let me actually give myself a little more space. I have my column, then this line. And then we have your index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. 13, 14. Oh, where is my writing? There we go. So I have written down, so therefore, if the column is on index number 9, I need to graph from 0 all the way up to 8, but not 9. So how can I do that on a substring? So message dot substring, it's from 0 all the way to the location of the column, which will be the index. Now, do I need to do, if the index was 9, do I need to do 9 minus 1, which will be the 8, or just index? No, just index. Remember that even whenever you do a substring, it's from 0 to index, but it doesn't include the index itself. It goes to the one prior to that. So one of the things that you want to be aware. And now let's go and get a description. Description will be equal to message substring. And where are we going to start? Well, we're going to start on index, which is the 9. So in this case, we are assuming, in this case, your index will be 9. So the one that we're going to start is the one after. So it'll be index plus 1. And because we're going all the way to the very end, we don't need to include a comma. And that's it for our constructor. We don't need to return anything. We basically are going to just initialize your machine ID and your description. And notice that we're not including the column in there. Now let's go over to part B. Part B, it says, write the log message method, so which is log message method contains word, which is here. So write the log message method contains word, which returns true if the description of the log message properly contains the keyword and returns false otherwise. Now, for it to properly return the keyword, it must meet all 3 of the following criteria. And the thing that you have to be careful with is that it has to meet all 3 of them. And this will be the first one, the second one, and the third one. So it must meet all 3. First, the keyword is a substring of the description. The keyword is either at the beginning of the description or immediately preceded by a space. So it's either, so first, desk, it is in the description. It's not the beginning, but it is preceded by a space in here. So it meets criteria number 2. And the keyword is either at the end of the word, so in this case it is, or immediately followed by a space. So notice that this one, it meets all of them, because this is it's in the string, it's the first, and it's also the last, right? At the beginning and also at the end. In this case, it is part of the keyword. It's not the beginning, but it is preceded by a space. So it does meet criteria number 2. In criteria number 3, the keyword is at the end of the description. That is correct. And you can go through each one of them, but all four of them do meet the requirement. Now to code it, we just have to kind of go step by step. First, it requires that the keyword is a substring of the description. So let's go and create an index. It's going to be an int. So that way we can get access to where the keyword is located within the description. So description is the one that we're looking at, and we're going to get a substring of it. Not substring by a, we want to be able to find the location will be the index of the keyword. So now that we know where the keyword is located within the description, now we can start tackling each one. Now, because there's so many requirements, I'm actually just going to create a flag for each one. I'm not going Boolean. I'm going to create the flag for the first equal to false. Requirement number 1. The requirement number 1 is that it's a substring. Of description. Then I'll do a Boolean number 2. Flag 2. I'll initialize as false. If I can spell that correctly. And that was going to be the beginning of the description. Or will be preceded by a space. And the last one, the rule number 3, that all of them must meet, you'll be end of description or followed by space. And now let's go and deal with the first one. I want to make sure the keyword is a subscript. So now that one's the easiest one because we know that if it's index of, it's going to return -1 if it's not found. So as long as the index is greater than -1, we know that it was found. So therefore, if index is greater than -1, then we know it was found. So therefore, the flag 1 is equal to true. The next one, flag 2. We know that has to be at the beginning of the description, and we know if it found it is at the beginning, that'll be the index will be 0. So therefore, if index is equal to 0, or it's preceded by a space, or we want to be able to find that the previous letter or the previous letter is a space. So therefore, if I write down, let's go and write down the second one, error on disk. I'm going to write it in blue. And let me just place my index. And you want to do this on your APXM. Let's see, there you go. You want to be able to place your indexes underneath just to kind of get an idea of where each was located. So therefore, if the index is 9, then the space before it will be 8. So therefore, if message, the one before it, we're going to get the substring index minus 1, right, which will be the 8, to the next one. No, yeah, so we just want to get the space here. So be index minus 1 to the index. Now remember that in this case, index, even though it's from 8 to 9, 9 is not part of it. So the only thing that's going to return is the character before it as a string. And because we're comparing characters, so many of you guys are tempted to do a dot equal, a double equal sign, and no, we have to do dot equals when you compare two strings. Then this will be true. And let's see, we have my spaces in there. Now, one more thing that we need to be careful with is this index minus 1. If the index happens to be 0, then this will give you an error, correct? Because it's going to be, if it's not greater than 0, that's fine. We want to make sure that we include the index has to be greater than 0, or and so in case this is false, then it won't go into this message, because if the index is not 0, then it's going to calculate, or it's going to evaluate this expression, and that's going to give you an out of bound. So you just have to be very careful every time you use a minus 1 or a plus 1. Usually plus 1 is usually a little more forgiving. So in this case, it's going to be extra spaces in here. So if the index is greater than 0, if it's equal to 0, then it won't, because of the and this will be evaluated. If this is false, then it won't even bother with this statement. So therefore, if it's equal to 0, then it won't give you an out of bounds. So we have, if it's greater than 0, I believe I need an extra parenthesis in here. Oh, there we go. And just make a little more space. Then flag number 2, the second case will apply. And you just have to remember that you just have to go line by line on the requirements for this. So we've done part 1, we've done part 2. Now let's work on part 3, the flag number 3. If the keyword is at the end, so how can we do that? If the index of the word is equal to, so how can we evaluate that the index is the very last one? Correct. So we can say if the index of the word is at the very end, we can say the length minus the length of the actual word. Or another way of doing this is that we can just compare two different ways. So I can think of two different ways. You can just look at the description and say if the index is equal to the description minus, or I can actually just compare the last, evaluate once again. So I'm going to do either description, substring, is that more challenging? I think I can think of a different way. If I can say if the index is equal to the length of the word. So let's look at this one. Let's assume that it was 12. Right? So if the length is 13, let me write it. So the length is 13. The length of the word of the keyword is 4. So minus 4. That gives me 9. So therefore I can find it that way. So if the index is equal to the description, the length minus the keyword, the length, then that means that the keyword was at the very end. Do you guys agree? So the description length in this case is 12. Was actually 13, correct? Minus 4 letter for the keyword, that's 4, which gives me 9. So therefore, if the index is 9, then that means that it was at the very end. There's another way of doing it, but I believe this might be easier. Or if it's followed by a space. So we're going to say if the letter after that is a space, so let's say on this one here, if there was an extra letter, if it was an extra word afterwards. The. So if it was an extra letter in the extra space, so we're going to go on message, the substring. Let me place it on the next line so we can actually see a little better, because otherwise it might be too long. And from here, we are going to go, we want to be able to reach this space. The index is 9, the length of the word is 4, so we're looking at the 13th space. So we're going to use index plus keyword length, and let's where do we need to stop? So we need to stop right afterwards, right, to the 13th. So this is the 13th, so we're going to stop on the 14th. So it'll be index plus keyword, because we just want to be able to evaluate one letter, plus 1. If that's equal to a space, then, so let's go through the statement again. So this will be the index. So if the index was 9, plus the length of the word is 4, so we'll be on the 13th space here. From the 13 to the next one, which will be the 14, and that's why we have to add 1. Then flag 3 will be true. And now if all of them are true, remember all 3 of them have to be true, so we can just say if flag 1 plus flag 2 plus flag 3 is true, and not plus by and. If one flag and the other, if one of them is false, then it won't go into this statement, then we're going to return true. Otherwise, if one of them is false, then we're going to return false. And that's it for this method. So this is just the ones that you have to be very careful, the substrings. And you kind of want to be able to write things down, a little more space if you can. If you have graph paper, that makes it a little bit easier, and just space it out. And that's it. Now we have part C. In the array, they use the contain words, so that's the one that we finished. Perfect. Part C. So the system log contain class represents a log message. So in this case, we have the system log here, It contains the log message objects. So in this case, we have the variable is a list that contains log messages that are going to contain the log messages from this. So you're going to have to construct um, objects and place them into the list. And actually, they're all already coming in here, and they already create the constructor for you. So provides a method that removes and returns a list of all messages, if any, that properly contains the given keyword. So you're going to remove and you're going to return it. So any of the objects that the description contains the keyword, you're going to do two things. You're going to return it as a list, but you also have to remove it from the current list. The messages in the return list appear in the same order as they originally appear in the system log, and no messages contain proper keywords and empty list is returned. The declaration of the system log class is shown below. So they give you the variable, your instance variable. Remember, it's always private. It's a list of log messages called message list. That gets initialized in your constructor. Now, one of the things that you have to be careful is that your constructor, even though it's here, they might not show you on your actual class, and says there might be instance variables and constructors that are not shown. So even though you're able to see on your replet, it's not shown here. So let's go through Parsi. And actually, let me just go back, and we also have to make sure that we read this part. Assume the log message works perfectly, and you must use contain words in order to be able to get full credit. So let's go through the process. So we're going to return a list of all the messages that we gave raised. So we're going to have to declare and initialize a new list. So list, they're going to be the same type. So we also a log message. And we have to give a name, so we're going to call it deleted items or objects or messages. And that'll be constructed new list log messages. And we don't need to tell the size. And now we're going to go through a for loop, and I want to go through a for loop of all the log messages in my message list. And we're going to have to remove it. Now, one of the things that you have to remember is that whenever we remove items, we don't want to go from zero from we usually do this, and we have a message list.size. But since we're going to remove it, you want to go from the end to the beginning. So we're going to go from message list to but remember, in this case, if the size is 10, that means that the index of the last number will be 9. So you have to do -1, and we have to include an equal sign, and we have to do minus minus. So those are things that you have to remember whenever you go backwards. Now, if the message contains the keyword, so if, and remember that we must use the contain word. So if your message list, we're going to use, it's a list of a get I. If it contains the word keyword, then we are going to remove it. Now remember, let's go back to your contains words that we just finished. Your contain words, where is that? Contain words is going to just take in the parameter of keyword. It's going to return true or false if it finds it. So if it's true, and so therefore get contain words. If this is true, if it's in the list, we are going to remove it. Now we can do it in two steps. We can remove it and then add it to the deleted messages, or we can actually do it in one step. We can delete it messages dot add, and we're going to remove it from the message list. Now that's something that you need to be able to remember, is that whenever you remove an item, then you are actually, it's actually also returning it, so therefore you're going to be able to add it at the same time. Something that it says is that it must be returned in the same order. So if you go back, so if we are removing one, since we're going backwards, when we're removing one, this should be at the very end. When you're removing another one, that one should be before it. So therefore, whenever we are adding it, we want to be able to add them to the beginning, and the only reason why is because we're going backwards. And now that we remove the ones that have a keyword and we added them to the deleted messages, then the only thing that we need to do is just return the list. And that's it. So let's go and run it and see. Let me just take a second look and see. Colon, correct, list, new, size, -1. And sometimes I forget the double. When I go backwards, sometimes there are times I forget the double negative in here. I keep as double positive, increasing. So that looks good. So let's run it and see what errors. Let's see what errors did I get. Well, let's see. Single colony, probably saw that before I did. Quite a few errors. Here, let's look and see. Can I find the message? 133. Contains. So in this case, we are looking for the description, not the message. Same thing here, the description. And one last one, system log, and that is on line number 30. And let's go and do an array list. And let's see. So therefore, the first one is looking fine. The second one is not removing them. So it's not finding any of this. Let me just double check. For I, we're going backwards while I is greater than or equal to 0. So just be careful. A lot of times we talked about that. I forget that minus minus. Sometimes I have to remember myself that while I is greater or equal to 0. And let's see. And that does it. Let me just confirm that it's the same output that I need. And that looks good. So that is the solution for the 2016 log messages. Have a good day and I'll see you guys next time.